Thanks for the very generous introduction for all of us. And let's hope we are able to live up to the name and really talk about something insightful and hold your attention for next 40, 50 odd minutes. Uh, so, like Vikas mentioned, and the way I see this session is it's basically trying to align some of the things which were said in the keynote session right at the beginning, some of the challenges which face our industry, and then actually think of it as an opportunity, and that's why, the whole talk is titled as Digitally Uncover Profitable Pathway to Net Zero. So, just trying to summarize, so basically the way I'll capture this topic is talk about the challenges. This is something which was addressed in the keynote session by various speakers. Then talk about what we at Aveva call carbon chain optimization solution. And then, align it with some of the standards in the industry with respect to greenhouse gas emissions and energy management. And then finally conclude it with, some kind of suggested next steps as most of the operators embark on their net zero journey. So what are the challenges? And I think much has been talked about this, so I'll be brief. I won't go too deep into it. But on the screen, on your left-hand side, you can see a lot of investment is going into this area of net zero. So those are some of the top companies spending billions of dollars. On the other side, what you see is what are the technologies, what are the options available, what are the initiatives available to these companies as they embark in net zero. So the curve there is called carbon abatement curve, and then what it is signifying is what are the initiatives which you can take, how much carbon dioxide or GHG emissions they can abate, and what is the cost. Right at the beginning, you can see energy efficiency. So energy efficiency is something which can obviously bring down GHG emissions, and it comes at a negative cost, which means it actually pays for itself. As you are focusing on your energy efficiency, you are kind of reducing your fuel costs, energy costs, and also bringing down the emissions. And on the far end, you see things like carbon capture. Some of these things we have talked about. And looking at some of these things, at the bottom side, what you see, how most of the companies are thinking about it and going about it. So what they are saying is that what we can immediately do is go on to a more efficient operation. So look at your energy efficiency, look at your loss, and address them. After that comes the step when you are kind of slowly introducing low emission components into your supply chain or into your value chain. And these low emission components, I'm using it very generically. It could be low emission feedstocks, renewable feedstocks or blend stocks, or it could be equipment which are more energy efficient, because a lot of manufacturing capacity out there is of a certain vintage, and if you are kind of replacing it, and as the cost of energy and the carbon emissions goes high, it will become profitable to kind of start replacing them and think of more energy efficient components. So that's the kind of a next step people are thinking about. And then finally, you would have to, and this was talked about by various speakers earlier, you have to think about changing your operating model. Moving on to petrochemicals might be one step, but then, at the outer end of net zero journey, carbon capture would be a reality. There would be hydrogen production, maybe green, maybe gray. Those things are still to be played out, but essentially, instead of being a fuel supplier, you are becoming supplier of chemicals or a hub for low emission energy feedstocks or products. So those are the kind of things which, based on our survey of various companies and their visions, that's what they're thinking about globally. But the challenge is obviously far more difficult to address than with just those simple phasing. Because what you see here is carbon pricing. And recently in COP26, there was a commitment to come out with a framework of a global reporting framework for carbon emissions by each of the companies. So that one of the challenges which we have always seen with past clean development mechanisms, CDMs as we used to call it, or current carbon pricing and carbon trading is, how do you rely on information, correct? And that is being, the fundamentals for those things are being laid as of now. And pretty soon they will be a reality. Even besides that, there are a lot of jurisdictions in the world where carbon pricing is already a reality. So if you go to somewhere in Northern Europe, the carbon price would be in range of $150 per ton. In Singapore, where I come from, the current carbon price is $5 per ton. So it's there, and the government is thinking of increasing it gradually. And soon, some of those mechanisms you will find in India as well. So you can see that the whole carbon pricing and the economics will kind of play their role as we kind of go into the future. There's also another additional uncertainty. As per a recent IEA report, which, of which an extract is being presented here, for achieving even 2030 targets, only around 80% of technology is commercially available. For achieving a 2040 or a 2050 target, almost 50% of technology is not available. So there is even a technological uncertainty in deciding, how exactly to go about those phasings which I was talking about earlier. So what all this highlights is, while there are a lot of initiatives available, which are known as of now, but there is an uncertainty related to regulations, market dynamics, and the technology, which kind of actually prevents companies from laying down a clear path to net zero. It's not possible at this point of time. In lieu of that, how do they kind of address this challenge? And this is where what we call as carbon chain optimization solution comes in. It's not a set of new solutions. It's a set of solutions which already are well deployed by the industry. We have a lot of clients using these solutions, but it's a more enhanced and a more relevant, made more relevant for the current context of net zero. So what is this solution? So you see the circle out here. One part of this is what we call as carbon-aware planning. And this basically is just like a planning solution which typically you might be using, but it is slightly more enhanced by considering scope 1, 2, and 3 emissions. So this kind of a solution can help you plan what you want to do in your long term, or even what you want to do operationally, what kind of crudes you might want to buy, given any cap on emissions or carbon you might want to put. Next part of this is a process digital twin based energy and emissions management solution. And while the planning tool addresses something which is more economically significant, so you can decide what kind of capital expenditure you want to do, or you can decide what kind of a feedstock you want to buy, but there are a lot of decisions with respect to energy and emissions which have to be done more operationally. So whether to replace a drive, whether to do hot integration, whether to clean up an exchanger to drive more efficiency and hence reduce the energy costs. Those are the decisions which LP or the planning tool can't help you make. And that's where this process digital twin, which is kind of working on your energy and emissions management, comes in. It helps you take those decisions. And then finally at the bottom what you see is unified production and emissions accounting system. And what this solution does is, you are doing already perhaps your production accounting, but it is kind of aligning your production accounting with emissions accounting and coming out with single set of robust numbers which add up. And we'll talk about all of these in detail in subsequent slides. But I just want to kind of share with you how working together, these can take you to the net zero path. and that too profitably. So on the other side, what you see is a number of initiatives, a lot of them not yet determined, but this solution can help you identify that I want to take these initiatives in this particular order because they make economic sense. And then you baseline whether you have achieved whatever you projected using unified production and emissions accounting system, and then go further. As you make changes, obviously you will make changes to your process digital twin, you will make changes to your carbon aware planning, and from there on you can find out the next set of initiatives which will take you profitably further. Not only that, not only can it guide you throughout your net zero journey, the initial implementation itself can give you a gain of 5 to 10% because of the optimization features built into this. So if you're deploying it correctly, you straight away get those jumps using the digital technologies. And one more thing which I want to highlight, the way this solution would work is based on a plan, do, check, act kind of a framework. And it would help you do those iterations because it will bring a more techno-economic input into your planning targets. What kind of targets you want to set on your net zero journey and the achievement which you want to do as you go along that. And then also it will help you measure the gaps from your target in a much more robust and an engineering fashion. And then you can prioritize those actions based on those gaps. So it kind of really enables that PDCA approach to your net zero journey. So let's talk briefly about each of those aspects. So let's, starting with carbon aware planning, and the session, some of the panel speakers in the session before were talking about, I remember Arun mentioning that the final decisions will be made as to what their LP says. And that's where this carbon aware planning comes in. Because in a typical planning tool, what you're doing is you're talking about material flows. And in addition, what you can get an insight is, along with those material flows, how the money is flowing inside the LP tool, correct? And it'll tell you that where you can make more money, where you can make less money. In a carbon aware planning, the additional element which you are adding besides the material flows and the economics is you are modeling the carbon flow, the carbon intensity flow as well throughout your LP. So you're able to capture the scope 3 emissions contained in your feedstocks. Then when you bring them inside your refinery, you are able to model the scope 1, the direct emissions. If you are importing any electricity and steam, you are able to model the scope 2 emissions. And then finally, as you produce, you have the capability to model the scope 3 emissions of your product slate as well. And what this allows you to do is, as you can see, the green part is the future feedstock slate and the future product slate on the diagram. And as you plan to move slowly from your traditional feed slate of a crude and a mobility-based fuel products, you can gradually start evaluating which options make more sense immediately, and then subsequent years downwards using such a carbon aware planning tool, and hence bring more rigor to planning your net zero journey, which is based on pure economics and obviously the process constraints and the technological availability. The next, what we can talk about is once having planned, I just wanted to kind of add this particular component in there, is having done this planning, let's say for next 2-3 years, what is also key is closing the loop on planning. And that's where a unified project and engineering view comes in. Because the technologies which are available nowadays can help you quickly do a sustainable design. So you can quickly evaluate the renewables, the potential of the renewables, the potential of some of the green technologies like hydrogen, and then come up with a configuration and feed it into a more detailed engineering and a process engineering kind of an environment. and all this happening digitally. So you don't lose time transferring data and collaborating across different teams using more traditional methods. So you are able to seamlessly transition from sustainable design to a unified projects and engineering kind of an environment, quickly do your engineering, including working and collaborating with your EPC contractor, if it's a big project, or if it's an in-house project, delivering it, trying to do the engineering yourself. And then finally, coming to the point of a quick handover and a flawless handover in a startup, which takes you to full throughput pretty fast. Because this is one capability which will be valuable, because the time will be a constraint as people try to come up with various kind of projects in response to the environmental challenges which we see. So this will be a key capability, and you can see there is a significant benefit to approaching this whole cycle of project and engineering from a digital perspective. You can significantly reduce the amount of effort which goes into engineering, the amount of, there could be schedule reductions and the cost reductions you can drive, making you more agile to take on subsequent projects in a very fast fashion.
Satyendra, you have 5 more minutes.
Thank you. So quickly moving on to the digital twin part. And let me explain this concept, because what this process digital twin is trying to do is, it is trying to calculate the reduction potential. And this reduction potential is for energy and for emissions. So typically when you are operating your plant, you would kind of benchmark a particular process based on some kind of a static data. This could be past year's performance, it could be benchmark from other refineries, but you would have some kind of a static number which is kind of saying that this is how I'm going to review the performance of my process. And when you compare it with your current average, you sometimes see current average go up, sometimes see current average go down, and you might take a judgment call, okay, you have performed good this time, and you have not performed good on the other occasions. But coming from process industry, we all know that that's not the entire truth, because how you perform with respect to energy or even emissions depends on the severity of your operations. It depends on what kind of feedstock you're processing. And depending on those, the situation might be seen a little bit differently. So the bottom curve which you see, if I'm able to neutralize for these conditions, if I'm able to neutralize for the severity of operation or the heaviness of the feed, then what I get is the best achievable, best practically achievable energy consumption or emissions. And then when I compare it with the actual, that is what is the true reduction potential in the process. And if I'm able to track it over a period of time, then I can prioritize that these are the areas, if I address, I will get a consistent and a sustained advantage rather than just comparing it with a static benchmark. And that's what is the reduction potential. And this gives you a true picture of what are the areas you need to address, and also at the same time be able to monitor whether when you have taken an action, you are truly addressing this particular point or not. And this is something which is driven by process digital twin. You can augment it with some kind of emissions modeling also to make the emissions predictions more robust. So you can imagine a first principles process digital twin and augment it with some kind of an AI where predictions become sometimes a little bit more challenging. So that is the picture of a process digital twin which is able to do energy and emissions monitoring. And in this slide, I just kind of give you an overview as to how this works. So basically, what you're doing is you're taking the plant data, reconciling it all in real time, then kind of tuning the model online there itself, and then optimizing it. That's the traditional cycle of a process digital twin. But to kind of make it work for energy and emissions work, what we do is we take in the tuned parameters and then run it in another mode, which we call as green optimization mode, to calculate what is the reduction potential. And then finally, coming to the topic of unified production and emissions accounting. This is something which most of the people do. So they do production accounting. And when you are doing production accounting, one thing which you're doing is you're calculating fuel and loss. And if you reflect on it, fuel is nothing but goes out as emissions. And if you look at loss, you can possibly have losses of emissions, effluents, and solid waste. And then remaining part will be some kind of an unaccounted loss. So the message here is simple for this particular application, that you have to do your production accounting, but with a deep focus on fuel and loss. And on the loss side, you should be able to break it up and kind of account for all the emissions which are happening, and especially the bulk emissions. If you are able to do that, then you will mathematically add it up. You know, your production, your loss, your emissions, everything should mathematically add up. And it's just an enhancement of an existing solution. And in fact, it's not new. There are a lot of people following best practices who have been practicing this. They have been regularly embarking on loss management programs where they kind of bring focus into various kind of losses, and chief amongst them would be the emissions. You know, whether these are process fugitives, whether they are flare losses, and just by bringing a consistent focus over that and running it for a couple of months, we have seen clients bring down their overall losses from, let's say, 0.5% to even 0.2%. And each point percentage there implies not only benefits in terms of profitability, because you are producing more out of less, but also reduction in emissions. So finally, how all this comes together. You know, like I was trying to say, that you have, you need to generate your plan, your targets, which are more methodical and scientific. Then you should be able to track, do, check, and then finally act on those. And then, of course, re-baseline where you are, and if needed, again, plan again, do the planning side again. So basically, you can follow a framework which is more like, something like your what you follow for your energy management, ISO 50001, which is again based on plan, do, check, act kind of a framework. And for next steps, I encourage you to kind of get in touch with us or one of my colleagues out here. What we suggest for you is to kind of review your current systems, basically. You can review your current planning systems, your current optimization systems, your current LP systems, and see whether they are capable of meeting this challenge of net zero and take you there in a profitable fashion. Thank you.